Hello everyone and welcome back to Learning at 11th Hour. This video is going to be about the basics of two-port networks. So in this video I'll be discussing about the definition of what a port is, and I'll tell you the different parameters that are involved in a two-port network, and following which I'll be going into the basics of Z parameters and I'll conclude with an example problem. So let's dive into the video. So let's begin with the definition of a port. A port is a pair of nodes across which we can connect any device. So if I have two nodes in this manner, then I can connect a device across it like that. So this put together becomes a port. So if I call this as port 1, having two nodes, and say I have my input coming in from here, then I can get my output from the other side of the device, call it as port 2, having two other nodes 2 2 dash. And in that case, this could probably be a linear passive network. So the first thing that we need to note here is, if we have a single port linear active network, which we have been discussing all this while, then there are different methods to analyze them. For example, we can simplify them and represent single port linear networks using the Thevenin's equivalent circuit or the Norton's equivalent circuit. Now, when we have four terminals in this case, right, 1 1 dash 2 2 dash, so this is a four terminal network or a two port network, then that can also be analyzed, but the way of analysis is different in this case. We're not going to arrive at any Thevenin's or Norton's equivalent circuit. We're just going to use some parameters, port parameters, to conclude the behavior of the circuit. Now, here we have just four terminals. We can have more than four terminals entirely, right? So you can have a network having, say, n ports, and the voltage and the current variables associated here would be 2n. Why do I say so? So let's look at this two port network. The current that is entering this node is, say, I1, and this same current is going to leave the other pair of these two nodes. And similarly, if I have I2 entering over here at node 2, it will be leaving 2 dash as I2 itself. This is one thing we need to understand. And if the voltage across 1 1 dash is V1, this is the voltage across port 1. Here we'll be having V2. That's the voltage across port 2. So if you notice, there are I1, I2, V1, and V2. So four current and voltage variables associated with a two port network. So essentially, the voltage and the current variables are just the double of number of ports that are associated with this network. So if it's a two port network, four current and voltage variables. So if it's an n port network, we'll have two n V and I variables associated with it. Now, these voltage and current variables, they can be arranged in any order, in any manner, and it could be arranged into groups of two with uh, n variables in each group. So you can have different permutations and combinations, and therefore we will get, for an n port network, we will get 2n factorial by n factorial whole square possible ways of arranging these v and I variables, and therefore these become the types of port parameters. So now if I replace n with 2, then I will be able to obtain the number of port parameters or number of types of port parameters associated with a two port network. So we see that uh, for a two port network, it is 2 into 2 factorial by 2 factorial the whole square, which is effectively 6. So we get 6 types of port parameters associated with a two port network. Now, what are these 6 parameters? So, for a two port network, we will have the open circuit impedance parameters, also called as the Z parameters. We have the short circuit admittance parameters, also called as the Y parameters, the transmission or chain parameters, also called as the ABCD parameters or the T parameters, the inverse transmission parameters, the hybrid parameters, also called as the H parameters, and inverse hybrid parameters, also called as the G parameters. We are now going to look at the open circuit impedance parameters or the Z parameters for a two port network. So, say this is how the two port network looks, right? So, there are two ports. This is port 1, and on the other side, we have port 2. I1 and V1 are the current and voltages of port 1, and I2, V2 belong to port 2. So, we can actually frame the equation in this manner. So, we can say V1 is going to be I1 Z11 plus I2 Z12, and V2 is going to be I1 Z21 plus I2 Z22. Or we can represent it in the matrix form in this manner. V1, V2 is equal to the Z parameters Z11, Z12, Z21, Z22 multiplied with the current matrix. So this is my Z matrix, and Z11, Z12, Z21 and Z22 are the Z parameters. So we can look at each of these in detail. So Z11 is, from this equation we can understand in an easier manner. We can find out what Z11 is. If we consider I2 is equal to 0, then Z11 simply is V1 by I1. So Z11 is V1 by I1 considering that I2 is equal to 0. So if we consider I2 is 0, it means that port 2 is open. And we see that V by I is nothing but an impedance. It's an impedance, right? So we call this as the driving point impedance of port 1. Driving point impedance of port 1. Similarly, we can find out Z22. So Z22 over here can be obtained by considering I1 is 0. So we can say Z22 therefore is V2 by I2. V2 by I2 considering I1 is equal to 0. And this becomes the driving point impedance at port 2. So Z11 and Z22 are the driving point impedances. Next we have Z12 and Z21. So in order to find that out, Z12, which is over here, we can consider I1 is equal to 0 and it becomes V1 by I2. So V1 by I2 considering I1 is equal to 0. So this is again open circuit, because if you look at it in all of these parameters, the current is 0 and the current becomes 0 only when we have an open circuit, which is why we call the entire set of parameters as open circuit impedances. All of these are actually impedance values, V by I. Here, the only difference is this is V1 by I2, which is why we call this as the transfer impedance. In the similar fashion, we can obtain the value of Z21. So Z21 can be obtained as V2 by I1, considering I2 is equal to 0. So V2 by I1, I2 equal to 0 is also again a transfer impedance. So here we have 4 Z parameters, two of which are the driving point impedances Z11, is the driving point impedance of port 1, Z22 is that of port 2, and Z12 and Z21 are the transfer impedances. Let us now look at a simple numerical where we will be asked to compute the Z parameters of a given network. So, say we've been asked to obtain the Z parameters of this given network. So, this side, that is the left side of this network, I can call this as port 1, and this side, the right side, is say port 2. This is 1, 1 dash. This voltage is going to be V1. This current is I1, which would come out from here. So I1 would be in this manner. It'll enter ZB. And from here to 2 dash with V2 as its terminal voltage, I2 would enter this terminal in this manner and come out as I2. So I have marked the voltages and the currents. I need to compute Z11, Z12, Z21 and Z22. In order to do that, all I need to do is I need to bring or frame KVL equations and bring it in this form such that I can identify my Z11, 12, 21 and 22 from there. So I'm going to apply KVL in loop 1 and 2. So for loop 1, what I have is V1 is equal to I1 into ZA plus ZB, because I1 enters both. So ZA plus ZB plus I2 into ZB. So this is for loop 1. Looking at loop 2, I can say V2 is equal to, let me put I1 first, because this particular equation has the I1 term first and then the I2 term. So looking at this, I1 into ZB plus I2 into ZC plus ZB. So these are the two KVL equations. Now I have these two equations exactly in this form. So I can just write out the coefficient of I1 in my first equation as Z11, the coefficient of I2 in the first equation as Z12. So here we have ZA plus ZB is Z11, ZB is Z12. Again, in the second equation, coefficient of I1 is Z21, coefficient of I2 is Z22. So ZB here is Z21, ZC plus ZB is Z22. So therefore, you can summarize the Z parameters in this manner. Z11 is ZA plus ZB, Z12 is ZB, Z21 is also ZB, and Z22 is ZB plus ZC. So that's all with today's video. I hope you've understood the concept of Z parameters from the two-port networks by watching this video. If you have any queries, please don't hesitate to post it on the comments. Please do subscribe to this channel, and thanks for watching.